being recorded.
Hello everybody, and thank you for joining us today. My name is Jonathan Pollock. I am the CUAHSI User Support Specialist, and today we have our second to last Spring Cyberseminar. Today we have Dr. Alva, who is a professor of computer science at Tufts University, but is also now actually the director of the CUAHSI Water Data Center. So today, I don't want to steal too much of his thunder, but Dr. Couch will be talking about some of the priorities for the first year of the data center and some of the costs and some of the benefits and some of the items that he's prioritized for us. And so without further ado, Dr. Couch, please take it away. And just as a reminder, this meeting will be recorded and will be available on the CUAHSI website. If you should want to be notified when this meeting is available, please send me an email. My email address is jpollak@cuahsi.org. Alva?
Good afternoon, everyone. First off, I'd like to do a few things in this talk. I would like to define the roles of the Water Data Center and how we're going to be doing things and interacting with the community. I'd also like to open a long-term dialogue with the community that is going to have certain themes. I would like to develop some of those themes today because some of these things are very new to this community. I need to actually develop and define a language with which to express the burning issues. And I have many things on my mind that are burning issues about the future of the data center, and I would like to begin a dialogue, but not finish a dialogue on what the data center should actually be. Now, first of all, we were just funded. We were funded by the National Science Foundation effective April 1, 2013. We have hired already 2 software engineers, Steve Pilot and Marie Martin. The last one just started this week. And user support continues to be provided by John Pollock, our Master of Ceremonies. And we are just getting going. We're still in the phase of training ourselves on what we need to do and setting priorities and setting goals. I'd like to share some of those with you today. Now, first of all, many of you might know that I signed on as director only for a single year. I have to do several things in that year. I have to move things that we have called prototypes into things we'd like to call or be comfortable calling products. I have to move from informal to more formal agreements with users and data publishers. And what I mean by that is we really need to lay out what it means to be a publisher and what it means to be a user of data. For example, we really do need people to, my phone is ringing. We need people to understand the responsibilities of being a data publisher. And so I'm working on a document that will describe what the responsibilities are. There's also a responsibility for data users to do appropriate citations of data. And so we'd like to spell that out. The other thing is that I'm going to be moving from unmoderated to curated data sources. Now, what I mean by that is, so far, we have thought of a data source as something that someone puts up, and it's really a best effort thing. And we would like to go to the point where that data service has some guarantee of continuing to function. We'd like to have an understanding about what the minimum requirements are for metadata. And that means that we're going to be seeking out data providers and asking them politely to give us more metadata than they might have given us so far so that their data is discoverable. But most important, the last bullet item is the central core. We need to move from best effort to service level objectives. Now, what that really means is as follows. So far, many things we have done have been best effort in the sense that we have been a volunteer organization. We have had the volunteers pull their weight and make some personal sacrifices and deal with problems as they could, but we didn't have anybody necessarily particularly responsible for a problem. Now, we need to make a transition to the point where the data center is, in some sense, responsible, and that means that we need to make some hard decisions about exactly what the service levels are going to be and what is actually going to happen when something goes wrong. Now, I first want to comfort you. There have been many rumors that I would like to shift the whole data support structure to standardized formats, that I am going to do radically big changes in the data infrastructure, et cetera. And that's not really true at all. That's the last thing I would do. HIS Central Catalog will continue to run, and it will continue to support Hydro Desktop the way it always has. Hydro Server, WaterML, and Water OneFlow services will continue to be supported. We are going to provide options to them, but we're not going to deprecate them or remove them quite yet. Also, the translators from non-WaterML formats to WaterML formats are going to continue to be supported, and they're going to be expanded. So none of these things are going to go away. User support will continue for Hydro Desktop and Hydro Excel and other data clients that we already support. And I want to point out that Hydro Desktop development is continuing now. And we might talk a little bit about that at the end when we talk about the future of things. Now, first off, what am I planning to do now? The first priority is to take control of HIS Central, which is currently still running in San Diego, and run it in the Azure cloud. This is actually not a major project because Azure is designed to take things from the Microsoft environment and port them to the cloud. I also wish to improve search speed via parallel computing. Everybody has told me that one of the biggest problems is the response time for a search in Hydro Desktop. I wish to increase precision of search queries and results, and I'll talk about that in some more detail. Precision is a technical term. It means that you don't get what you don't want. I'm also going to try to improve the site registration and harvesting processes for putting new sites into the central catalog. There are some deficiencies I would like to address. In general, I would like to improve catalog quality via rigorous curation and also computed metadata, and I'll comment more about that in a second. And the last thing, and I'm going to talk about this in some detail, is that I would like to enable linked data in catalog and servers. And so I'll talk about that in some detail in a few seconds. Now, first of all, there's a basic problem with discovery precision. First, we have to make sure that metadata is complete, and that means that we're going to have to go ask people for metadata that's not actually published right now. We're going to make a survey, make sure that we have what we need for discovery, and ask anyone who doesn't provide it. It's fine if they can't provide it, but if they can, we would like to complete the metadata in the catalog as much as possible. There are still many nulls in the catalog. The second thing we'd like to do for discovery is to allow users to search for variables instead of just concepts. This has been a common request, actually. It has been either an implied request or a real request from a large population of people who've talked to me. They know what variable they're looking for in the variable control vocabulary, and right now we allow them to search for concepts but not for variables. So I'm going to be putting up services that allow you to search for variables instead of concepts. The other thing we're doing is making a considerable amount of progress in allowing users to specify other facets of search, such as, for example, information about the data provider, or information about method, or other issues such as the level of the sample, et cetera. Many, many different things in the metadata that one can use to locate a particular data series of interest. And finally, this is actually a bit intensive, but I think it's necessary. We're going to make somewhat of an effort to compute derived data quality metadata. For example, frequency counts, median values per month, the frequency of nulls or unknown values in data, et cetera, and add that to the faceting. So that gives you an idea of some of the things we're going to do to improve precision. Another thing that has come up over and over again is that the current registration process involves a lot of hurry up and wait. You register the server, you wait for the harvest, and you tag variables. Now, one of the problems with this, and it's a very significant one, is that the user who's actually registering the service gets completely inadequate feedback as to whether they are using the control vocabulary for variables. One of the things we would like to do is to make it exceedingly easy to use that vocabulary, because that's going to improve search precision incredibly. So the proposed process is as follows. It gives immediate feedback upon registration. When you register your server, it goes out and instantly harvests, comes right back to you and tells you, here is what I just harvested. So you see what you actually did with your server. It allows easy correction of errors almost immediately, and it allows immediate tagging using the community-moderated variable control vocabulary. Now, that is not currently the way it works. Right now, there is a time lag between a time that a variable is put into the community-moderated vocabulary and the time that it becomes available as a controlled vocabulary variable in HIS Central or for tagging. And so what we're really going to try to do is to make registration a one-stop process and, in fact, integrate the community moderation and the process of tagging so that you don't have to go to two places in order to define a new variable. And I think that's a very small thing with really major ramifications for ease of use. Now, when I try to actually improve the catalog, we have to ask some really difficult questions. You can measure data discovery in terms of two factors called precision and recall. Precision is the extent to which what you get is precisely what you want. In other words, something is precise if you get what you want and you don't get a lot of other stuff. Recall is the extent to which you want is part of what you get. And the problem we have right now is that our current search services, if you simply watch a user, you can validate this for yourself, have very high recall and very low precision. Now, what I mean by that is you always get what you want somewhere, but it's sort of like a Google search in the sense that you get something you want out of many, many results, and then you have to go search through them and have a more precise estimate of what you want based upon subsetting. Now, the problem is that catalog curation alone, just fixing the nulls, just using controlled vocabularies, it improves recall, but it doesn't actually improve the kind of precision we're needing. And one way to improve precision is a rather revolutionary concept called linked data. Now, there are a lot of rumors going around about what linked data is, so I'm going to make it really simple for you. Fundamentally, this is the process of including semantic details in data that relate that data to other similar data. Now, there are many forms of linked data, but I'm going to concentrate on the simplest possible form, which is linking via metadata. I'm going to use the metadata, that is, the data that we utilize to locate data of interest, as the basis for linking. And I'll show you exactly what I mean. Now, here's the basic idea. Currently, we have words and terms that describe data. For example, I'm going to use the word nitrogen to describe something we can measure in a variety of ways. What we're going to do is to translate these words into uniform resource indicators, otherwise known as URIs. And unlike a word, a URI is very powerful. It can embody meaning and synonyms, and even synonyms in other languages. And if I want to get a little more complex about it, it can embody subclass and superclass relationships, whether something is more general a concept than something else, or perhaps more specific. Now, before linked data, this is how the world looked. In HIS Central, in this case, I'm going to bring up a pointer. In this side of the diagram, HIS Central, we have a data set that has metadata with a word called nitrogen. Now, locally, to us, we have some synonyms for nitrogen, but they're actually different than the synonyms that other people use. So, in GIOS, we might have something measuring nitrogen. We would have the exact same keyword, but we would have other synonyms. We'd have something different from our synonyms. And there was basically no way to communicate across this link. The link from word to word was not powerful enough to express the global idea of nitrogen. Now, if we look at the post-linked data phase, we gain one thing that's incredibly powerful. The first thing we're going to do is not to record a word nitrogen. We are instead going to record a quasi-SCOS URI. This is the Simple Knowledge Organization System, or SKOS, and we're going to record that as a link in web space. That link will contain a number of things. Most importantly, it will contain cross-references to other SKOS sites. This cross-referencing is a hard reference, whereas the word match nitrogen to nitrogen was a soft reference. This cross-reference is a really hard reference, and it's going to point out, so for example, that this term is the same as the concept of nitrogen in the GEOS, the Global Earth Observing System of Systems catalog called GEMIT. Now, what that does for us is very subtle and very powerful. We now have a path from the data set through the SKOS URI in the metadata to the other site in GEMIT to synonyms in foreign languages. Now, what that means is we get internationalization for free. So if we can make that map, and if we can then make the appropriate cross-references, we're going to get our terms translated into 23 languages. Now, personally, I would much rather have the people at the Open Geospatial Consortium translate those terms into 23 languages than doing it myself. And so it is a very high-value thing for me to create this cross-reference, which is, in essence, a synonym relationship between the two SKOS references. Now, the point is that this cross-reference is embedded in my URI. It's embedded in the actual description of my concept, and that goes to this website, which explains a number of synonyms proposed by others, and also explains the 23 languages in which that synonym can be expressed. So this is something that's really low-hanging fruit. We're going to get a lot out of this very simple idea. Now, the importance of this is really powerful. Before linked data, synonyms are a local concept. If I say the word nitrogen, then I have my own concept of what it's a synonym of. After linked data, synonyms become a global concept. And that means that I can assure that the URI that I am using means the exact same thing by means of that cross-reference link that I showed you as the synonym that someone else is using, regardless of where the other person is in the world. And that means, in particular, that I'm going to be able to search in foreign languages, which is an unbelievably powerful idea. So the short-term plan is really quite easy. I'm going to expose our variables via SKOS services. This has never been done before. Our concepts have been exposed already in the EDSC system at CUNY, but unfortunately our variables have never been exposed. We're going to embed SKOS links in the HIS central metadata. In other words, rather than recording the name of a thing, we're going to record a link to the definition of a thing. Now, users don't even have to be aware of this. It's something that a user doesn't even have to see, but we are going to have to make Hydra Desktop a little smarter because it's going to have to know how to deal with these links. However, we're forced to do that by other things, and so I'll get into that later. We're also going to return SKOS references to HIS central queries, which means that Hydra Desktop is going to be informed of the broader terminology and what it means. And finally, we're going to cross-link our SKOS services and other SKOS services, including the GEOS system and the EDSC system at CUNY, which is developed by Michael Piasecki and Associates. So the net result of that is this will be greater than the sum of its parts. And in fact, if we can do this with our data, we can also then utilize other SKOS servers, for example, for biological taxonomy. And that will give us a huge win because we will not have to develop that taxonomy. That is going to be an unbelievable win. So, I've talked so far about the immediate priorities. What's on the immediate horizon? Well, I await with bated breath final specifications for ODM2, and I await that because eventually we're going to have to do WaterML to native. I also am looking forward to interoperating with the Global Earth Observing System of Systems of the Open Geospatial Consortium, and I'm in talks with them about how to globalize the data that we have and about how to make it available, for example, to people in Europe. Now, for example, We're expecting ODM2, the Observations Data Model definition, this summer. That's going to require changes to HydroServer for it to put out ODM2 data, and that is going to, in turn, produce native WaterML2. You might be aware that now we're transducing things into WaterML2. And that, in turn, is going to require changes in the catalog so that we know where that data is and how to deal with it. And the most important change is that one of the key attributes of both ODM2 and WaterML2 is going to be the ability to use linked data. We're going to be able to specify those URLs, and all I've just done by specifying that I'm going to deal with them is to impart meaning to that. And so that's basically all I've done, and everybody else has done the hard work of figuring out where you would put them and why you would put them in. Finally, there's a thing that I consider a bit controversial that I'm working on. And it's controversial because CUAHSI has, in essence, always been a United States organization. I'm looking to interoperate very seamlessly with the Open Geospatial Consortium's Global Earth Observing System of Systems GeoPortal. I would like CUAHSI time series to appear in the GeoPortal maps. And I'm actually negotiating with them a fairly simple way of having that happen. It turns out that key to that is linkage to their vocabulary servers, because we do want to be able to search in their terminology. But it also turns out that there are fairly simple ways that we can support search for them without giving up the idea of how we do search for ourselves. And so while a number of people think, well, we really should just drop our own search services and go with theirs, I disagree. I'm going to keep our search services up until we like theirs better, which is a fundamentally different statement. And we may never like them better. We may like ours better forever. But I am going to support theirs. Okay. Now, even at the longer term, after we get started, we're going to have continuing partnerships with scientists and industries to extend the state of the art. You might have noticed that everything I've talked about so far is to tune or otherwise make more usable the current state of the art. For example, the HydroShare project is going to enable sharing of bundles of data rather than just time series. We're working with them to create a reliable data access layer for them for our data. EarthCube wishes to enable interoperability between different kinds of services providing different kinds of data. We're giving them a platform upon which to do one of their experiments. Plug-and-play sensors are another grand challenge, fun thing that we're thinking about. Can we enable vendors to streamline to such an extent the deployment of their sensors that it takes nothing more than a few simple operations to go online with the data? Those are just examples of some of the longer-term goals for the end of year one and into year two. But now we come to a changing point in the talk. I want to expose to you how I think about these things, because in order to think about them really effectively with the community, we need to understand each other a little better. I've told you a lot about what we're planning to do, but so far I haven't justified it at all. Turns out I know exactly why I want to do it. I'd like you to understand why we do things. I'd like to develop a language for you to understand that why. And I'd like to allow you to speak that language with me so that you can, in a very proactive way, make an argument to me that something needs to be done differently. The biggest quandary that I face as director of the data center is a comparison between cost and value. You might be aware that we're coming up on a pilot budget. It is not a large budget. The costs that we can incur are limited. On the other hand, we need to have high value. And value in this case is actually expressed in terms of people using our services. We are not a for-profit. We measure our success in terms of people actually utilizing what we do. So we have to do something that is low cost, high value, compared to many of the other data centers which have been in existence for many years. Now what that means is that we're going to have to define areas for improvement, and we're also going to have to think carefully about service level objectives. That is, what can we do for the money that we have? And we're also going to have to quantify the cost and value of each improvement and each objective. Now, this is going to lead to a rather long discussion, and I'm going to try to walk on some common misconceptions. Because as director of the data center, there are some realities on my desk that might not be on yours. Now, how does this really work? First of all, the final authority is the CUAHSI Board of Directors. I work for them, and I'm not going to go against them. I am going to communicate with their designees, the Users Committee, which sets user priorities and objectives, and the Informatics Standing Committee that talks about infrastructure priorities and objectives and product priorities and objectives. Those two committees are going to define value. Now, the director's view of governance is really quite straightforward. The board and designees set priorities. That's scientific worth, merit, enabling potential, etc. The director predicts and tracks cost. Now, what is really going to happen is not one transaction. It's a dialogue. They will say, I want something, and I will say, it costs this much, and these are the things I can't do because of it, and we will have an ongoing dialogue to figure out what I actually do. Because only the two of us together can balance cost and value. I cannot do that by myself. I need input from the scientific community, and as I told you before, I'm a computer scientist, not a geoscientist. So, the director's view of costs is not exactly what you would consider a view of costs. I think it's rather uncommon for an end user to actually have this view. Everybody knows that labor isn't free and that putting something on a computer isn't free. I mean, everybody knows that you pay electric power to put something on a computer, so that isn't free at all, even if you own the computer. But the other problem is that data storage isn't free and speed isn't free. It is not a priori true that you can just store something somewhere and forget it. It isn't a priori true that you can get an arbitrary performance or speed for a data search. We actually pay money for those. And their cost depends upon what we're going to call service level objectives. Now, setting those objectives is not a one-way street. It is actually a dialogue between me and you, or between my successor and you, etc., about that trade-off between cost and value. I would like to walk on a common myth. Many people think that if you just create a disk and put it on the web, that that's storage. Unfortunately, it isn't really true. You pay for volume of storage. You can quantify that. You pay in time of storage, which is months, usually. You pay in transactions when storage is accessed, transaction charges, and a good unit to start to understand storage cost is dollars per gigabyte per month. So, some benchmarks that you can understand from cloud computing. The least expensive storage I've been able to find is 7 cents per gigabyte per month. And that means that if you have something a year, you multiply 7 cents by 12 for how long that it stays. Also, you multiply by 1,000 for terabytes. The most expensive storage that I've found is 15 cents per gigabyte per month. And that gives you a bit of an idea of the actual quantified cost of storage. The nominal cost is about 10 cents per gigabyte per month. And the breaking news is I just got a press release from Azure that they're reducing their cost to 10 cents per gigabyte per month to compete with Amazon directly. So this is a rather important piece of breaking news because I would otherwise be highly motivated to move to Amazon. Now, let's talk about this slide just a little bit before I go off of it, because there's a very key issue here. In designing the data center, I considered many alternatives. I didn't find anything that was cheaper than this nominal cost, including spinning up my own infrastructure. The reason is that in order to get that 10 cents per gigabyte per month, you have to consider the entire life cycle cost of the installation. To get a large installation, or essentially unlimited storage, you have to make a huge initial capital investment. Once you factor that, plus the cost of maintenance, you end up with roughly the same figure. Now, to understand that a little better, let's talk about a common myth. I'm going to buy a $150 3 terabyte drive. I'm going to put it on the web. I'm going to put some data in it. Am I done? Well, I would say emphatically not. I have too much experience with this. There are several questions I would ask about that model. What happens if it fails? What happens if I step on it? What happens if I spill my Coke on it? How long does it take to recover when it fails? Is it ever going to recover? And how quickly can several concurrent users access it? My point is very simple. Making a $150 drive reliable, persistent, and highly available costs a lot more than $150. In fact, a considerable amount more. To understand that, let's talk a little bit about the nonlinearity of storage pricing. Last year, I did a very simple study of storage pricing and took a look at the trends in how large disks cost. I found a discontinuity, and that discontinuity is actually easy to describe. If you're looking for less than 10 terabytes, you can pretty much get it for now $50 a terabyte. It's relatively low reliability. There's no recovery strategy, and that's a fairly simple home device. So the deployed means is home video. I think last year it was $1,000. It's gotten cheaper now. If you go above 10 terabytes, there's a discontinuity. All of a sudden, rather than $1,000, you're paying $15,000 or $20,000. Why? Well, they're not made for the same market. The 10 terabyte device was made for a personal user who really doesn't care how long it takes to read the video, and is not going to be competing with anybody else reading the video. On the other hand, the greater than 10 terabyte device starts being an enterprise device. And so we need several things that an enterprise would need: high reliability, fast recovery from problems, high request capacity, etc. The disks become more expensive because they have to be hot swappable. The hardware becomes more expensive because it has to handle hot swapping, etc. The net result is an interesting discontinuity in disk cost, which, until you look at it carefully, doesn't make any sense. But in fact, I think it makes complete sense. In running a data center, I have to think beyond the 3 terabyte drive on the internet. You have to pay for high reliability. The data source is not going to stop working. And high persistence is when you put something there, it stays there. It doesn't disappear. High availability says that it handles multiple requests at the same time. It's not going to fall down when multiple people try to use it. And finally, there's an issue of quick recovery. In the unlikely event of a failure, data becomes available again quickly. Now, all of these add cost to a disk drive. And all of these are why there's a discontinuity between user drives and drives meant for professional use. Now, the biggest challenge I have is going to be educating you, the users, as to the difference between best effort and service level objectives. I cannot, as a data center director, with a straight face, tell you that my data services are best effort. That's just not how a data service is run. And you would be very unhappy users if I told you that that data service would be best effort, and I would get around to it when I got around to it. Well, on the bottom of the slide, there's around to it. That's my old joke. I'm giving you around to it so that then one can get to doing something that one didn't do before. The typical service level objective for a production service is that if something goes wrong, there's a reaction time. We'll be back online in an hour. Maybe for a more serious thing, we'll be back online in a day. For something even more serious, we might be back online in a week. But the point is this: we need to establish expectations, and we need to be able to stick to those expectations. I cannot, with a straight face, tell you that I'll do it when I get to it. That's just not the right answer. And that means that I'm going to have to develop infrastructure that allows me to make those guarantees. So, to give you an idea of the real problem here, let me take you behind the scenes. I estimate that we're serving up about 70 terabytes worth of data right now. And in my opinion, according to a study I made last year, about 10 terabytes of that is at risk of disappearing without notice. Now, What I mean by that is as follows. There are lots of services out there that could disappear if funding ends. There are lots of services out there that could disappear or fail to be recoverable when a particular graduate student leaves. That means that I have a problem as a data center director because I'm running a distributed service, and the most frustrating thing in the world is to have a data source come up, be exactly what you want, be located with high precision, and turn out not to exist. That's the basic question. Is the value of backing up the 10 terabyte worth the cost? Well, I answered that question. I budgeted for 10 terabytes worth of backup space. And so I've already budgeted that at the 15 cents per gigabyte per month, and I'm hoping that that will be sufficient to protect us from these contingencies. I would like to have some way of knowing whether or not that data is going to stay around. But there's a deeper issue. Ever since I took this position, and long before I was funded, I've been approached with a great number of brilliant ideas. Most of these ideas involve hosting a data product at the center. And traditionally, hosting that product has been a gigascale problem. There were at most gigabytes of data, so we were paying not very much to host them. For example, the current catalog is about 100 gigs. It varies depending upon how you measure it, and when you add all my indices, it's about 150 gigs. But that gives you an idea of its size. But the problem is that now people are coming to me with terascale data. They want me to host that. We're dealing with satellite-derived products that deal with huge amounts of data. We're also dealing with climatological model outputs people would like to make public. I have a really burning question there, and it's a question that is not going to be answered anytime soon. Is the value to that community worth the 10 cents per gigabyte per month? Which translates to $100 per terabyte per month, $1,200 a year. This is a significant amount of storage, and no matter how we slice it, and no matter how we create that storage, and there are different options that I can go over with you, we're still paying that. And so there's this basic question of what's the value of storing things in a high availability format. Now, what do we do if we take away some of that? Well, I'll tell you honestly that there are other things that we can do. It might seem that that cloud rate of 10 cents per gigabyte per month is very expensive until you compare it to the life cycle cost of setting up that large storage array. It's actually the same rough life cycle cost, but an astronomical startup cost, because you actually have to spend a few $100,000 starting up, and then you assume that that's going to last 5 years. So, pretty much paying the same thing. But if we go beyond that, there are other options. One thing that I've been exploring a lot is nearline storage. Nearline storage means that for things that are really big, you can drop the cost to 1 cent per gigabyte per month, which is to store something on tape, move it to disk when requested, and have people wait for it to be moved to disk, because obviously moving from tape to disk is slow. But tape is still the cheapest, most reliable medium for terascale data that there is. So that's one option, is to cut the cost to 1 cent per gigabyte per month and make people wait a day. Another concept is that of unreliable caching. We're going to store the data in a large rack of slow, lower quality disks. We're going to refresh that cache from the web periodically, and don't back it up. Very different life cycle cost. You go down from $1,200 per terabyte per year, whatever, to $100 per terabyte per year, and you have to include network and electricity costs. What's the disadvantage? It's rather obvious. Unreliable caching is unreliable. There's no SLO. I'm not going to get it back. You see, the big deal here is that by putting all of my money into disk and just completely forgetting about the concept of restoration, I can actually reduce the cost of the thing by factor 12. But do I really want to do that? And the question is, are either of these acceptable for users? Now, I think we all know what the components of value and cost actually are. Value for me, and actually for the board as well, is the number of users enabled. There's also value in new capabilities and uses, and there's value in scientific and transformational impact, if we can provide a kind of data that transforms someone's research. There's also intangible value in education, outreach, and visibility. Cost factors that I have to include are probably more comprehensive than what most people consider cost factors. Labor and computing cycles are obvious. Data storage and transaction fees are something that exist in the cloud world in an explicit sense, but actually exist in any data center in an implicit sense. I have to think about software licensing and how much I have to pay. And furthermore, just to be complete about it, I have to think about electricity. One of the most commonly ignored cost factors is how much electricity it takes to run infrastructure, and it's substantive. Now, I'll leave you with a very simple overall view. I have a curve in which, I'll bring up an arrow, value is on the x-axis and cost is on the y-axis. I want to do things that have high value. In other words, they want to be over near the end of the x-axis, and I want to couple that in some sense with their cost. Now, this is of course an exaggerated scale, but this gives you some ideas of value versus cost. Well, there are some things I'm going to do that are going to have a high cost. Catalog and data curation are human labor intensive no matter what we do. And so it's going to cost us some human time to make the catalog a really quality catalog. Improving search performance is actually a bit of infrastructure cost and a bit of programming cost, but it's certainly not as big a commitment as making the catalog clean. Linked data is actually a rather low-cost thing. It's not a very big change in anything. And so it's just a matter of storing and putting out what we already know. And searching for variables is very low impact. That's not going to take much time at all. On the other hand, there are some more general things that take a little more cost, but they actually have very high intangible value. For example, interoperating with GIS. Now, the reason that I think this is important is that this will actually put our data on the radar, on the personal radar of many more researchers. And that will give us a global exposure that we simply don't have right now. Finally, I put this one up in the cost because actually, to tell you the honest truth, I don't know the best way to do this. But one of the grand challenges is to adapt satellite and radar data products to the use by water scientists. There are many proposed approaches. I don't know which one's going to work out. I think it's going to take a while to do that. It's high in the value department, but not as high a value as some of these other things because of the number of users affected. Right now, it would affect less users. Now, it might be that someday we'll readapt this and move this over up here when people know how to use this data. But right now, we're in the nascent and very beginner phases of this. And so I do not believe that we have the answer to this at this time. But that gives you a director's big board of what we're doing in the next year. I'll open the floor to questions.
So thank you very much, Alva, for the presentation. I know I'm sitting here on the front lines, and I definitely learned a lot, and I'm hoping everyone in the audience did as well. So at this point, we'd like to open it up for questions, and if you have a question, please go ahead and type it in the chat box. And once we start answering your question, we can unmute your line if needed to facilitate a discussion. You can either unmute your line if you have a mute button by pressing that or by pressing *6. So I have a question for you, Alva. What do you think are some of the biggest challenges with the priorities that you see coming up here?
Well, to tell you the honest truth, the biggest challenge I see in the first year is coordination, because we're going to have to actually push out a new revision of HydroServer. And that means that we're going to need to coordinate the actions of 90 people. We're also going to have to modify in slight measure the Hydro Desktop protocol to allow the use of these more powerful URIs. And that's going to require some revision control. And so far, the catalog has not had or enjoyed that revision control. There is provision for it, for revision of the protocols, but it has not been invoked. And so I think that the most worrisome things to me are that I have to accomplish these major rollouts of ODM 2.0 and of linked data URIs without any disruption to users. That's a neat trick. And I think that in this, one of the reasons it hasn't been done so far is because of the need for coordination and the difficulty of that particular coordination. And if I had to worry about something, that's what I'd be worried about in the first year.
And while you're reading Jeff's question, John, this is Rick Cooper, let me just jump in too. I wanted to just point out to the audience that Alva's laid out a lot of big questions of what the community has to give feedback for, and the way we do that is through the user committee and through our standing committee. And so we'd have to give you more information about that, and just drop John or me a line if you're interested in participating in those committees. This is really the way we're going to get feedback into Alva, and there's a number of levels to participate in this. So I just wanted to make that pitch if people are interested.
Yeah, and I want to make it very clear that I serve you and not the other way around. At present, everything I've said in this talk is my best effort estimation of what will best serve you. But if you have better ideas, I want to know about it. And I don't want you to be quiet, and I don't want you to think that I would be offended. I am here not to pursue a personal agenda, but to pursue the agenda that you folks consider most fitting and proper. And I will always listen. In fact, none of this was done in a vacuum. Everything that I told you about today, some user mentioned to me, and in some cases, large populations of users.
So we have a question from Jeff. Can you touch upon some of the reasons you chose Azure as a cloud platform instead of Amazon Web Services or any other services?
I'll give you one simple answer to that, and that answer is changing very quickly. Right now, Azure was the path of least resistance because it was possible to move things to Azure with a minimum number of changes. In fact, some things that I have done recently might have me question that decision, because some of you probably are aware that HIS Central itself has been ported to Linux. Now, it was ported by the folks in Italy, and I'm very thankful to them for doing that. I actually gave them a copy of HIS Central, and I let them do their experiments and to see if it would work for them as part of a new push toward internationalization. And in doing so, I got back an unbelievable payback in the sense that they wrote me 3 weeks later and said, oh, by the way, we have a Linux version. Now, I am beyond excited by that. And that means that my previous idea that Azure is the way to go might have to be questioned in the near future. Now, I'm going to have to validate that Linux version. It's actually written in Mono. It's written using the Mono toolkit, which is the .NET for Linux. I have to validate it. I have to make sure that it's good. But it's going to be also validated by several data centers in other countries. And I think that's fitting and proper, because this is a perfect opportunity to make this thing open to a wider audience. And I'm paid to keep data for U.S. researchers. And I would love it if people in other countries funded someone to keep data for them. That would be fitting and proper and good. That I'm willing to empower them to the extent that I can. But the short story is that Azure was a really good fit. The reason it was a really good fit is that 90% of these queries are queries into SQL. There is a Microsoft Azure SQL, which is a very close work-alike for Windows Server and SQL. And the basic impact of that is it takes very little time to port to Azure. And so that was my main reason for choosing Azure, and I will point out that I am very excited to have more choices in that right now.
So we had another question come in about accessing the presentation slides, and I will be posting them on the CUAHSI website as PDF, as well as a recording of this presentation in video format. So if you'd like to be notified when it is available, please do email me at jpollak@quasi.org. So it looks like we might have one more question coming in, Alva. So we have a question from Bronco. When talking about the storage requirements, are you referring to the storage of metadata or time series data? My understanding is that time series data will be stored at non-Quasi hosted servers and discoverable through Quasi web services.
Not necessarily true. Right now, we actually serve up a small amount of data. It's in the 5 terabyte range. But that is a moving target because there's much dark data on the internet for people who can't afford to run their own servers, and we're actually going to try to go after that dark data. The data dark data is a new term for data that just doesn't get published anywhere. That means that in the future, Quasi services are going to be there to publish data without running a Hydra server. Now, people are saying we have to get rid of the Hydra servers. Well, not really. The dark data publishing is a small thing for us. It's not going to cost us a lot to capture some of that data. And we're going to target people who, for one or another reason, can't afford to run their own Hydra servers. Also, I would note that there's an increasing need for data products focused upon the hydrologic community. We're looking at a number of different data products that have been demanded by users. One of them is high-resolution rainfall. Another one is flow models, etc. And so these data products, some of them climatological, some of them hydrologic, all of them requiring a lot of computation, are things that data center is looking into hosting. Not pointing at somewhere else, but actually hosting. And one of the reasons for that is it's just not cost-effective for other people to host them. And so we are not saying that we are only serving the catalog. It was true at the very beginning of this project that we only served the catalog. At this point, we run one server that people publish data on. We run another server that people send data to us to publish on. We have a number of data sources that are operated by us. And we feel that it would be a good service to the community to take up the dark data and to put that data somewhere where it can be accessed. And so that's no longer true. But in doing that, I face a real quandary because of our size. We are not that big. And so I'll be searching for options. One of the options we have is begging the people with lots more disk space to host it for us. For example, we're looking at whether the NOAA could do products for hydrologists specifically. We're looking as to whether there could be transformations from satellite data to what are called data rods that would be hosted at other places simply because of the storage requirements for maintaining them. And we're also thinking about the possibility of modeling on demand, which is to say, we don't actually store the data, but if you want it, we can get it. And those options are fundamentally more than what the original catalog would do. So we are looking to the future, we are looking to serve the community, and we are looking to things beyond just getting data from other people. And we feel that the data center should take an active role in serving the community at this task.
Thank you, Alva. So do we have any more questions? If not, I'd like to remind everyone that this is the second to last cyber seminar for the spring series. Next week we will have the concluding seminar from Jeff Horsborough at Utah State University. His talk's entitled Using Quasi-HIS to Support Large-Scale Collaborative Research in Utah. So similarly to our first cyber seminar, which was Sue Brantley at Penn State, this is another application of HIS. It should be a really interesting talk. as was today. So Alva, I'd like to thank you again very much for the presentation, and I'd like to thank all of our audience members for joining us today. And again, please feel free to contact me if you'd like to be notified when the recording and slides become available. We have a couple people typing, so I'm just waiting to see. Okay, thank you, David.